quadratic test over right before the holiday, but everything was equal. Everything was about, y equaling whatever. Now we're going to look at what happens when they're not equal. Greater than or less than, or maybe greater than or equal to or less than or equal to. Laptops, please put them up. Now, back when we were just graphing linear equations, do you remember when we used a dotted line and when we used a solid line?
Yeah, solid. There's no line. When it was like
Greater than or equal to gave us a what? A solid. If it had that equal to underneath it, it was part of the solution, so it was always a solid line. Same thing for parabolas. So if it is greater than, y is greater than or equal to, less than or equal to, your parabola is going to look just like it's always looked. But if it is y is less than or greater than, you'll still have the same looking parabola. It will just be dotted. Okay? So that part should be, like, this lesson today is like extremely easy as long as you understand parabolas. Okay? So, less than is going to give us they call it a dashed parabola. I will call it that as well. We're just going to write a dash. Now, if it's a solid parabola for less than or equal to, it's still going to be less than. Or equal to. And then, of course, if it's greater than or equal to, it's going to be a solid parabola. And if it's just, this sign means it's greater than. I think y'all know your signs. Now, x squared minus 4x plus 4. Yes, it says y is greater than. So are we going to have a solid or a dotted parabola? You should be able to, yeah, you're going to know that right off the bat. Yes, I'm trying to make it zoom. There we go. So here is our equation.
Dr. Graham, what did you write on the very right?
Greater than. I was just in a hurry because y'all know your signs. That was just what the sign would be. All right, so what we're going to do is graph and shade. We're going to pretend that that is not a greater than sign. Treat it as an equal, just like you would do when you were doing linear equations. So how would you factor x squared, or how would we graph, I guess, x squared minus 4x plus 4? What do we need to have? Hint, right here. Yes. Opposite b over 2a. Very good, Mercy. So opposite b, that's going to give us positive 4 over 2a, which gives us what? 2. And when we divide that, we get?
But it's opposite.
That's right, thank you. 4 over 2 gives, I was going to say that's not what I have over here. 4 over 2 is going to give us just a plain old 2. Then when we plug that back in, what do we get? 2 squared is what? 4. 4 minus, all right? Negative 4 times 2 is 8 plus 4, and that gives us 0, because that'll be negative 4 plus 4. Everybody good with that? Yep. So here is our vertex. Now, notice, y'all, if you had factored that just to check your work on it, you would have gotten x minus 2, x minus 2, and you would have had, again, x equals 2. That's another way to just kind of check to see if it's working for you. Still have, the root is 2. So we're going to run over here, and we're going to plot at 2, 0. And then we're going to graph. Lead coefficient's 1, and it's positive, so we can use 1, 3, 5. So over 1, up 1. Over 1, up 3. Over 1, up 5. 1, 2, 3, 4, 5. And then over 1. Notice, guys, that what was our C in the equation? 4. What's the y-intercept in our graph? 4. All right, another way to kind of double check yourself. The symbol, though, is our inequality is just greater than. So it's going to be dotted. Ooh, that's a horrible arrow. There. And then... All right, any questions at this point? For the inequality, we now have to figure out whether we're going to shade below it, which means everything on the outside, or above it, which is everything on the inside. So this is greater than, so where are we going to shade? Above or below? Above, which means inside. Now, if you get to this point and you forget which way makes it work, you can do a test point, which I'm not going to ask you to do that, but you can always grab 0, 0 and see if it fits. And you would have gotten, I think Z is greater than 4, and that's not a true statement, so we would shade not where 0, 0 is, but on the other side. So we've already, and on this one we established it was a dash, and we shaded above. All right. See what you can do with number 2, example 2.
Use this chart.
That's for Hensley.
Okay.
She has to use it, but no one else does.
She's gonna use it. I do whenever I'm working though.
I don't blame. It's a great way to check to see if it's right. All right. What is your B? Opposite B?
0.
0.
Oh.
So our vertex X part, your axis of symmetry is going to be 0. Ah.
Is it 0, 0?
Nope.
No, 0,
Go
-9.
0, -9. That's going to be your vertex. 0, -9.
When your y-intercept be -9?
And it should cross. Yep. And that, yes.
There's not -9 on our graph.
I know, but there's an 8 and then 1 dot below. I know, it fell off.
Wait. Why is the vertex 0?
Whoops.
There's
There's no, x squared plus bx, that would have been your opposite b, and there's not one, so it's 0. And then over anything is 0. And then x squared is 0 minus 9, -9. All right, so there's our vertex, and it is a happy face. And A is 1, so it just goes over 1, up 1. Over 1, up 3. Oh, y'all finish it. Y'all finish it and tell me where it graphs.
How do you shade it? Yeah, how would you shade it? Would it be?
Less than, so below.
Would you shade all of this? Because it's.
Uh-huh.
Mm-hmm. And if there was a graph below it, like right here, we would shade.
You would still, yeah. What's up?
I was commissioning call next. What's up, Doc?
I'm recovering from strep throat.
While you were out of the country or out of Boston while you were
No.
No? Okay.
Just while I was at home.
Okay.
How'd you get it if you just stayed at home for all week?
Like, my dad is also sick. And we live in the same house, so. I don't know how I got sick. I just did, okay?
And if you had factored this, you would have gotten plus or minus 3, and it crossed at positive 3 and negative 3. And it tells you that C is negative 9, and that's where we were. Dashed or solid? Solid. And then are you going to graph below? Shade above or below? Some people have already established it.
So you just shade everything outside of the little,
So you're going to shade
out of the jar?
like that.
Okay, what's a good time?
It's 2
All right, you do number 1. On the next page, the you try.
What is 2?
So what'd you get as the vertex, just so you don't go
-1.
vertex?
Negative 1, 4.
Negative 3.
Negative 1, 2.
I got 2.
Is it not 2?
Negative 1, 2. But remember, you square, so what did you get as your axis of symmetry?
Just say -1.
Negative 1.
And then negative 1 squared is 1, but it's got the negative out there, so it becomes a negative 1
So negative 1 plus 2
plus 1.
is 2.
Yeah, negative 1 plus 2 would be 1, and then 1 plus 1, 2. Yeah.
So plug negative 1 into this. And then erase this into this equation. Wait, so what's the negative 1, 2.
Yeah, I got it.
So do you use
Is it going to be solid or dotted?
solid?
What?
Dotted.
Dotted.
Oh my gosh, because that's what I call it.
Because it is not or equal to. And are we going to shade above or below?
It's less.
Less than. Less than, so
Below.
below.
It's an angry face, right?
It is.
What do you mean? It's sad.
Sad face.
Sorry, Hensley.
It's okay.
So you should have gotten as your axis of symmetry negative 1, 2.
Okay, did the happy or sad? Or angry? Sorry, it was angry or sad.
And if you'll notice, it crossed the y-axis at 1, and that's what our C is. So we know we're hopefully on the right track.
For the next one, do you just shade below?
Shade the region of the quadratic equation.
After
hmm
you were saying that was sad. Is it outside the John?
It's less than. All right, is it making sense? See, it's not that hard of a lesson. You just got to remember your solids, your dotteds, less than or greater than.
Is this all the quest is on?
No, no. But that was a good call.
This is one of 9.
Okay, which one do we want to? We'll do this one next. Okay.
How many points do you think the quest will be?
I'm not quite through yet. Oh, I didn't open that one.
Huh? Watcher Graham, is your exam multiple choice?
No.
Yes.
Why would she
Oh yeah,
ever
I'll
do
fail
that?
for exam.
No, surely not.
Not every multiple choice?
Maybe a little bit.
I really don't know. I currently do not. Yes, sir. Except geometry.
Yes, this is it.
I actually thought it was easy.
The chemistry is on?
Pass to Stella and Morgan.
I'm so tired.
Why is it so tight?
Share.
It's like-
Okay, makes me nervous.
I'm so jealous.
Yeah, because I'm gonna have it for nice looking. That's it.
What's called Instagram.
She's not sharing.
I'm trying to look.
Do you have any more lemongrass drops? There is. Well, he wants
See,
it.
look. She asked for it. Kenny'd be grateful.
intersect.
I'm very grateful. Micah, did you get me shoes that I'm gonna?
Nope.
All right, y'all, does everybody have the sheet yet? Morgan, do you have yours? Thank
Are
you.
we already working on?
Trip, do you have this? Okay, here we go. All right, we're looking still at non-linear systems of equations. Non-linear, that doesn't mean they're not equal to, but means it's not just a line. So we're going to have parabolas involved. Remember systems of equations where we could do elimination, substitution, or graphing? We're going to look at graphing and substitution. And with this, notice you have a quadratic as well as a linear. And we've got to find in the first example, and some of them are both quadratic, just depends on what all you're given. The solution set is the set of points in which the equations intersect. You can have one solution, which means they just cross one time. You could have two or more solutions, or maybe they never cross. And so you would have no solution, which means they're, parallel or they're doing opposite things with each other. So, to graph, remember we're still looking at opposite b over 2a and figuring out, what the parabola, what the parameters for the parabola would be. And then we need to put 4x minus y equals 1 into what format? Y equals mx plus b. So we will, and then we graph both, and we're looking to see if or where they intersect. All right? So for this first one, it's going to be y equals what for the top one, for our linear?
Negative 4x plus 1.
Positive 4x.
Positive 4x
Minus 1.
minus 1. Because look at you being on target, Harper. He's awake.
Like mean.
But look, it's a negative y.
Honestly, that kind of was me.
Negative y. So 4x minus 1. And remember that negative 1 is going to be your y-intercept. Your slope is a positive 4. Is that ringing a bell? It's been a while since we've done this. So we'll start off at negative 1. And then 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4. Then what is your vertex?
Wait, have it?
Wait, what now?
No.
You sure?
Yes.
Okay. I'm going to change color just because.
0. 0, negative 1. Is that not your vertex?
I didn't, let's see. Whoops. So opposite,
B, so negative 8 over
2 times
times negative 2, so
negative 4. Okay, good. I was going to say, I could have worked it wrong, but
So negative 8 over negative 2?
I got negative 8 over negative 4,
So
positive 2. Is that,
The vertex of
all right, so opposite B, negative 8. And then 2 times negative 2 is going to be negative 4. So the x part is a positive 2. So do y'all see how we got the x? The axis of symmetry. All right, plug that back in to find your y. And what do you get? 2 squared is 4.
16 plus 8 is 2.
Put it in order, though. 2 squared is 4. 4 times negative 2, negative 8.
Squared.
Nope,
plus
we've already squared it.
16 minus 3,
Plus 16 minus 3,
so 5. Yeah.
5. All right, so that's our vertex. So 2, 1, 2, 3, 4, 5. All right. And it's going to be a frowny face. And the axis, the lead coefficient is 2. So instead of over 1, down 1, we're going to have 1, 3, 5. So that means we're going to have 2, 6, 10. Down 2. 6. And then over 1, down 2. 6. So, do you see where they crossed? Whoops. Ugh, my drawing.
Oh, these are match.
All right, do you see where we had one intersection? What's the ordered pair for that?
1, 3.
1, 3.
So that's your only solution?
For this one, that's your only solution.
What if you draw the parabol like a little bit off and it touches the other purple right there?
You got to be fairly precise. I know. Whoops. All right. Number 2. See what you do. So let me ask you this. If you're doing 1, 3, 5, what would be the next set? 1, 3, 5,
4, 10.
7. We've already done one like that before Thanksgiving. Is it counts 1, 3, 5, 7, not like that? Because we're going to have to use that on this one. So let's graph. The linear is usually easier. I mean, it's less to do. So y equals what? Negative 2x plus 3. Do the linear because you don't have to do all the figuring. So we can go to positive 3. And then negative 2. 1, 2, 1. All right, then what is our axis of symmetry? And what's the vertex?
The vertex is 2, -9.
2, -9. I'm going to change color. So 2, -9. And then 1, 2, 3, 4, 9. Lead coefficient is a positive 1, so over 1, up 1. Do y'all see how we ended up with 2 intersections? Counting by 1, 3, 5, and then putting 7 in there.
Yes.
And so what would be our solutions?
-2, 7. And then 4.
Wait, when do you know when to use a 7?
4, -5.
Whenever you have more drafts.
If I stopped right here at 5, you're not quite to the graph yet, to the linear. Just try it. You can just count over and see. If you had landed like right here, you know, somewhere, then no. But it lets you move forward. And
Does it matter what order you write?
nope, does not. Work number 3. I'm gonna fly like the wind. Fly like the wind. I think I'll put it at 11. Bye.
They replaced the fair one difference from John. So then you have to add
Wait,
Yes.
X equals like an hour.
Come on, guys. You work this one all by yourself. Number 3.
Is the
can you have
linear,
fractions?
is the linear X equals 3y minus 29?
X plus 21 equals 3y.
I couldn't go to sleep because they
Well,
popping up on my-
Wait, you've got to have it where it's just y equals.
Yeah, so have it, you have to divide by 3.
Divide by 3. So you have a slope. You can have a fraction slope.
You can.
Yeah, the slope can be a fraction.
Wait, so you
It's X
divide,
plus
Y
21
equals 1/3
equals
X
3y.
plus 7.
Divide all that X.
so it'd be y.
Y equals 1/3 x plus 7.
Okay.
And you could actually have, you ask, could you have fractions? Yes. I mean, your y-intercept could be a fraction. I mean, just in this case it wasn't, but the slope is. What's your axis of symmetry? I mean, the whole thing. What's your vertex?
We're not there yet.
Oh, come on, chop, chop.
-6.
-6. And then figure out what your y would be for that.
Why do you have that evil look?
Oh.
Throwing stuff in my ears, wagging.
Your
5
ears?
times 6 is 30.
12 times 6 is 72.
Yeah.
Okay.
Is that like a big number?
What'd you say?
No, it actually is. I mean, what I was thinking, oh, I'm going to have a big number here, and it's not for your vertex.
What's the number?
Let's see what you get. -6 what?
7.
-6 squared times, wait, so it'd be
So is
I
it
think it's 7.
36?
it's too many numbers.
I think it's 7 now.
I don't think so.
I thought it was 6.
So you would have,
I got 36 plus 70.
no, -36. Because there's that negative out there.
So negative 36 plus 7.
Plus 72 minus 32.
Do negative
What?
Plus
minus 32.
4.
Yep. -6, 4.
No.
That's your vertex. There's going to be a frowny face, and you're going to use 1, 3, 5 Luke Hush. And then tell me, y'all graph it, and you tell me what the solution
No
is.
solution.
Do what?
Is it no solution?
No solution.
Oh, well done.
Your graph, your linear is a little higher than your vertex. It never crosses the vertex. Are y'all good with that one? I want to do one more,
So you just write no solution?
or put the null sign. Take off with number 4. Both of these are quadratic. So that means you got to find the vertex of both, graph both, figure out where they intersect either once, twice, none, and go from there. So the top one, what would be your axis of symmetry? Or what's your vertex? We'll go there. -8 over what?
Over 4.
Mm-hmm.
So -2.
So we start off with -2. And plug that back in.
-9.
-9. Remember, this one's 2, 6, 10.
Is the next one -1, -10?
-1, -10. Uh-huh. Oops.
good, so positive 2.
Thank you.
It's making me tired.
I don't know why I did that. I appreciate that. -2, -9. And I should have caught it on the, where it landed on the y-intercept, and it's 2. Ooh, making a big old mess. And then
You just timed it on that.
2, 6, 10, and then -1, -10.
You go up before you go up to.
Do you mind?
Hold on one second. Zoom out on the graph.
It's not by 2.
And then the last, this one is -1, -10. So -1, -10.
It says 3 solutions.
So we know it crosses here.
What? Can you just see it?
You said you're very smart.
And this one's just 1, 3, 5.
Your Christmas tree is very big.
I just said that.
It's a Charlie Brown. So what are your solutions?
Well, you have 3. -2, -9.
I think we only have 2. Let's see.
But it intersects at the.
I'm getting up there. I don't,
Hobby Lobby.
let's see.
It intercepts at
-4,
-2, -9.
and -4.
The Skellies.
There's a Hobby Lobby.
-2, -9,
There's a Hobby Lobby.
and then 1, 2, 3, 4. -4, -1, and then it may, they sort of cross, but it's not at a whole number
Right there.
spot. Yeah, way up here, but it's not.
So is it -4?
I just did those two. It's up there, but
So you're gonna count off if it's like close like that?
No, the only thing would be if we did, we're not using a calculator on this. Hey, guys, otherwise we would have it, but no, for this. All right, questions on this? Kusha, y'all need to figure out how to settle it.
I'm sorry.
Then the next part. I put it in. Let's see. Where did it go? There it is. Yeah, I left it over there. I thought I brought all the pages with me.
I need you to dog.
Yeah, I wonder if I left it in the lounge. Huh. I didn't think. All right, let me.
It's on my paper.
Y'all have it already?
It's attached.
Okay, good. I was like, how did I lose this? Thank y'all. Go to the next page. I couldn't figure out how I lost it. I think it's this one. All right, good. So keep going, guys. This time, I should have known because we're graphing. I mean, using systems of inequality. So, looking at the systems, we graph. Now we're doing substitution. Shh.
Up here, please.
Well, you're doing a lot more than that today. The talking has been way too much. All right. So, for substitution, we need to isolate a variable and come up with two of the same variables and make those equal each other. So, for this first example right here, we can take y equals negative 2x plus 1. And then your next part, you already have the y saying x squared minus 8x plus 6. Okay? So do you see how we're going to take those? They both represent a y, so make them equal each other. So negative 2x plus 1 equals our x squared minus 8x plus 6. And y'all have done this before, but just linear. Now we're going to create a quadratic equation and solve it from there. So what do you get when you put them all together? X squared
Minus 2x
Minus
plus
6x.
minus 6x plus
Plus 5.
5. All right, then we're going to, you could use any of our options for solving, but factoring this one will be super easy. So what do we get when we factor?
X. And then
2 negatives, 2 factors that equal 5, that when we add, we get 6.
5 and 1.
5 and 1. So then what's our solution? What does x equal?
Positive 5 and positive 1.
Positive 5 and positive 1. All right, those are both x values. They're not an ordered pair. That's where it would cross. But now what we need to do is go plug in to the original. It doesn't matter which one. I'm going with linear, so I don't have to square things and do all of that. But you're going to take each of those separately. So you'll have 2 more solutions. And you'll have the y partner for 5 and the y partner for 1. So
Should be 5 negative 9.
5 negative 9. So you're going to have y equals, and I would just do the 2x plus y equals 1, plug that in where x is 5. So y equals 1 minus 10. So that's,
5 negative 9.
you would plug 5 in. So 2 times 5 is 10, and the negative 10 plus 1. And then what would the 1 be?
1 negative 1.
1 negative 1. Now, that doesn't mean all the time, Mercy, that you're going to have a calculator. Okay? So you may have to work some of this by hand. Just keep that in mind. All right, so did that make sense? How to set that up? So what would you do for number 1? And it's pretty obvious which one we would isolate. You could isolate for x if you wanted and treat y. But you already have a y equals, and then your y is isolated, is a single, has 1 as its lead coefficient, so you wouldn't have to worry with that.
So we have y equals negative 4x minus 2.
Y equals negative 4x minus 2. And so make those equal each other.
Once you add them together, can you simplify?
Mm-hmm. So two factors that equal 4 that when you add, you get 4.
What if I brought them all out positive?
Then it's wrong.
What do you mean?
Like, I don't have -2 on the outside, I just have 2. Does that move?
Well, if you're going to factor, you need your lead coefficient to be positive.
But yeah, they are, it is positive.
Well, you would only
What I
wait.
did was like, at the very beginning, I moved all of the ones on the left to the right. So they'd all be positive.
But y equals all the negatives. That would mean you had a negative y. If you make them all positive at that point, you've solved for a negative y.
Okay.
You need the y to, so it has, they all have to say negative, but then you can remove a -2 here.
So it matters how you bring it out?
Yeah, it does.
And it has to always be negative?
Well, no, your lead coefficient needs to be positive. The x squared needs to have a positive if you're factoring. Now, if you're doing quadratic formula, it will not matter. So what are two factors that equal 4 when, and then you add, you get 4?
2 and 2 and 2.
So what's the solution for x?
-2,
And it's -2. So what would y be?
6.
And then that's just the 1. Does that make sense? All righty. Homework. Let me pull this. It's the evens. You don't have the sheet yet.